If you were born 200 years ago and you wanted light after it was dark, your only option would be to burn something. Basically the chemistry is burning something, the reaction being so hot that it would produce enough heat to produce some light. And it pretty much was that way until electricity was discovered. It was quickly spotted with electricity you could make light with a spark. It could also be produced by passing a current through a wire, but the problem was the air would react with the wire and eventually it would burn out. The Victorians liked electricity and liked experimenting with it, and this was the sort of thing they would develop. This is a Geisler tube, so this has got air in low pressure. So we're very much just an interest object at the time. But it did lead to the more common use of other gases such as neon. The only discharge tube that actually became bright enough to be of any use industrially was the mercury vapor light. It could produce quite a bright discharge. It could be used for illumination. The only snag was that it was very greenish blue. There were, however, other metal vapor lamps in the running by now. A sodium light at full brightness. This has been the most efficient light source commercially available for the last 90 odd years, and it's only just being replaced or superseded now, and in fact the lamp has now gone obsolete and nobody manufactures it. The problem with it is it's monochromatic, it's yellow, you wouldn't have it in your house. What makes it so efficient is that the yellow spectrum from this lamp is right on the peak sensitivity of the human eye. First, the light bulbs that were generated used carbon filaments, and this brought normal electric lights into the home. It gives quite a warm light, a bit like a candle, but it does it by producing heat to the point where the filament glows incandescently. And the carbon filament was the first example of this type of lamp. Tungsten filament lamps produce light by producing a lot of heat, but they can go hot enough to produce quite a white light. The problem is they're not very efficient. Only about 20% of the actual energy consumption produces the white light. The rest is just heating, which we didn't really want. The mercury vapor light did get into the household in one way. They discovered that if you added fluorescent powders to the tube wall, they would convert the ultraviolet light you can't see into white light. And this became the fluorescent light. You see in the familiar looking fluorescent light. So fluorescent lights are quite efficient, but not as efficient as the sodium light. But at least these produce a white light. Meanwhile, in electronics, it had been known for a while that silicon diodes produced infrared light from the junction. Later, by modifying this junction, they managed to coax it into the red end of the spectrum and then further onto the green end as well. These LEDs tended to be used for signals and displays. With the invention of the blue LED, this opened a lot of opportunities. And one of the amazing things with the blue LED was it didn't just go into the blue spectrum, it actually also went into the ultraviolet. Because the blue LED produced ultraviolet light, phosphors could be used again like in fluorescent lights, and that would allow some white light to be produced. This particular LED light here uses phosphors that produce a yellow fluorescent effect. Because the blue of the LED is underneath, when they mix together they will produce white light. And the white LED changed everything. Today the LED lamp basically outperforms every other light source. It is now more efficient than your fluorescent tube and equals that of the old low pressure sodium lamp, but also gives you colours of any part of the spectrum. If you found this interesting, you might like the other videos on my YouTube channel.